Hello, everybody. We're starting a new unit on chemical reactions. So this is an important unit in chemistry. Chemical reactions is how we make things in chemistry, similar to what you do in the kitchen. How do you make things in the kitchen? How do you make a loaf of bread? How do you make a cake? Well, what you would do if you didn't know how to do it is you would find the recipe. In chemistry, the recipe that we use for making things chemically is a chemical reaction. So here on the top, you can see a chemical reaction for how we make water. On the left-hand side, we have hydrogen. The hydrogen molecule represented by the formula, which is H2. Oxygen represented by O2. And then if you combine those and react them chemically, you can form water, H2O. Another way to write this, for the H2, I'm going to write two open circles that are touching. That means that they're chemically bonded together. And then for the oxygen, I'll have two circles, but I'll put stripes in them to indicate that they're oxygen atoms. Then we can make the water, which is two hydrogens attached to an oxygen. So on the left, you'll recall we have the reactants. On the right, we have the products. On the reactant side, we have a mixture of two different types of molecules indicated by the plus sign. And then we have the arrow. That means that that's a chemical reaction. That's where the molecules on the left side, they rip apart, they come back together, and they form the products, which in this case is water. Now, you might see a problem here because we started out with two atoms of oxygen, and then we only ended up with one atom of oxygen. So something's fishy going on because atoms cannot just disappear. So to fix this, I'm going to put a 2 here as a coefficient. So I need two water molecules. And now that fixes it. Now we have two oxygens on atoms on the left, and we have two oxygen atoms on the right. But that messes up the number of hydrogens, so I have to figure out how to fix that. I have 4 hydrogens on the right, only 2 on the left, so I'm going to put a 2 here. And I need another molecule. So now everything is correct, and that is the recipe for how you make water. And this is what we're going to be doing in this unit. So let's get started, but before we do, I'm going to get rid of my image so that there's a little bit more room to work with. So here, it's just practice to count the number of atoms in our sample. We're going to put it into a formula, and then we're going to use that formula to write a sentence, describe it. So here, the open circle is hydrogen atoms, the striped circle is oxygen, and the solid circle is carbon. Let's just take one of these. Notice that it has a carbon attached to an oxygen. So that is the formula for the molecule, but there is 1, 2, 3, 4, 5 of them. So I have to put a 5 there. Now to describe this, I'm going to say 5 molecules of carbon monoxide, right? That's the, if we remember, that's how you name this molecule, right? These are two non-metals, so they share electrons to form a molecule. What about the next one? So let's take this one first. We have hydrogen, but if you look in the molecule, there's 2 of them, so I'm going to put a 2 here. And then we have oxygen, and there's 2 of them. Now notice that in this case, the hydrogen comes before the oxygen. I mean, we could have written the oxygen in front of the hydrogen, but it's just by convention that the hydrogen goes first. Okay, but notice there's 2 of them. There's another one there. So what do? Well, I have to put a coefficient 2 there. And then I'm going to put a plus there because there's actually another molecule in there, which is H2O. Now, to indicate this in a sentence, I'm going to say a mixture, right? The mixture is indicated by this plus sign. A mixture of two molecules of hydrogen peroxide, and that is the common name. We could also say dihydrogen dioxide, but I'm going to use the common name, which is hydrogen peroxide. And this is the chemical that you use in the beauty salon to, for example, dye your hair. We also use it for an antiseptic when we get a cut. We can go to the medicine cabinet and we can spread a little bit of hydrogen peroxide on the cut. And if you do that, you'll notice that it kind of bubbles and it stings. And what it's doing is it's killing all the bacteria. It's a chemical reaction that kills all the bacteria that may have got into your cut. And then, of course, we have water, H2O. We could also call that dihydrogen oxide, but we like to call H2O water. And then the last one, notice that we have four of these, and three oxygens chemically bonded together. So I have 4O3, that's trioxide. So I'm going to write a mixture. And I don't like to write trioxide. I'm going to use the common name, which is ozone. And you've seen this molecule before. It's a very important molecule. It protects us from the rays of the sun. There's a layer of it up in the stratosphere, up in the upper atmosphere, and it filters out bad rays, bad ultraviolet radiation from the sun. And then we have two carbon atoms, a mixture of ozone and carbon atoms. Now, obviously, I could put 4 ozone molecules, and I could put 2 carbon atoms, but in an actual mixture of these two, you would have millions upon millions and trillions of trillions of trillions of these molecules together, even in a tiny drop of this material. Okay. I'm going to use my eraser here real quick. Okay, so in this exercise, we're going to count atoms. In order to do what we're going to be doing, which is balancing chemical reactions, we have to figure out, if we have a formula, how many total atoms of each kind are there. So in the first one, we have 3 dinitrogen oxides. So you can picture this as an oxygen attached to 2 nitrogens in some manner, in some arrangement. Okay, so, but we have 3 of them. Now, each of these molecules has 2 nitrogens. If we have 3 of them, 3 times 2 is 6. So 3 times 2 nitrogens is 6. I can draw that out real quick. Now, once you do a couple of these, you're going to find that you can do this in your head. So there's 3 of them. Each one has 2 nitrogens, so that's 6 nitrogens total. But then you have this N2, so you have to add 2. So that would be 8 nitrogens. How many oxygens? Well, 1, 2, 3. Okay, now we have the calcium, the next one, 5 calcium nitrates. Calcium nitrate is an ionic compound, so that we don't say dinitrate. We know that there's 2 nitrogen nitrates just by the nature of the charges, as we remember from the ionic bonding unit. So there's 5. So I'll write it over here. There's a calcium, and there's 2 nitrates. So each calcium is attached to 2 nitrates. Okay, so inside each of these formulas, these compounds, there's So we're going to do the calcium first. There's only one calcium, but there's 5 of them. So 1 times 5 is 5. What about the nitrogens? Well, 5, each of these compounds has 2 nitrogens, so 5 times 2 is 10. What about the oxygens? Each of these has 6 oxygens each, right? There's 2 of the nitrates. Each nitrate has 3, and there's 2 of them, so 2 times 3 is 6. And then there's 5 of them, so 6 times 5 is 30. So we know there's at least 30 from the calcium nitrate. But then we have 2 oxygen molecules, and each oxygen has 2, so 2 times 2 is 4, plus 4 equals 34. Okay, so that's how you do those. I think a quick way to do that is you just multiply the coefficients multiply the subscript. You have to be careful though, because when you have parentheses, you have to figure that out. So 5 times 3 for the oxygens. I'll do the oxygens. 5 times 3 is 15, times 2 is 30. And that's where we got our 30. So 5 down here, this is propane or propanol. 5 times 3 is 15 for the carbons. So I got 15. And then I'm going to add that to this 3 times 1. Okay, for the hydrogen, 5 times 8. 5 times 8, that's 40. And that's all the hydrogens there are. For the oxygens, 5 times 1, there's only 1 oxygen in each of these molecules, that's 5, plus 3 times 2, that's 6. So 5 plus 6 is 11 oxygens. Okay, draw an atomic level picture that represents chemical change. Well, that's easy. Why don't we use our water example? And then we make water. And here's the arrow. Now to fix this, remember, I can't have atoms magically appear and magically disappear, so I have to do this. Right, so this is H2, and there's 2 of them, plus O2, and then we get 2H2O. Okay. Introduction to chemical reactions. So here we have an equation. So what we're going to do is we're going to take this equation and we're going to put it into a sentence. In the above reaction, blank are the reactants. So I'm going to say, and I'm going to use English for all of this. So I'm going to say 2 carbon atoms and 1 oxygen molecule are the reactants, right? Reactants are on the left. And blank is the product. 2 carbon monoxide molecules is the product. So these are the products. This equation could be interpreted by saying that 2 atoms of carbon react with 1 molecule of oxygen to form how many molecules of blank. 2 molecules of carbon monoxide. Okay, so that's your introduction to chemical reactions, and a lot of the things that I showed you in this video, it really kind of summarizes what we'll be doing for the rest of the unit. So if you understood what I just did, you should be doing fine. So I'll see you in the next video. Bye-bye.